Okay, this lesson is for Unit 3, Lesson 5 for Algebra 2, and this is vertex form of a quadratic equation or inequality. Now again, we talked about this in last lesson. Quadratic means that we have x squared in the problem. That's our highest exponent is a squared, and whenever we have x squared, this quadratic, it always makes the shape of a parabola. So that's our U shape or a rainbow shape. Last time we did it in standard form, where we wrote it out, it was like maybe like x squared plus 2x plus 3. You know, we had an x squared, an x term, and then a constant. This time we want to write it in vertex form. Now, the benefits of writing it in vertex form is we don't have to use a formula to find the axis of symmetry or the rest of the vertex. Okay, this is very similar to when we did vertex form of absolute value equations. So vertex form of a quadratic equation is f of x equals our a value, and then in parentheses x minus h, all of that is being squared, and then we have plus the k value. So now this a, h, and k values right here that I'm drawing little tick marks by, we had those in our vertex form of absolute value functions. Okay, so they kind of play the same role here. We say the vertex is found at the value h comma k. Now this is like when we did absolute value functions. If you're looking at the vertex form equation, we have a negative h in the formula, and then when we write the vertex out, we say it's hk. That negative has come off. Again, that is showing that we take the opposite sign of whatever that number has in the parentheses. When we pull it out to write our vertex, we give it the opposite sign, okay? So hk is the vertex. How do we find that axis of symmetry? Well, the axis of symmetry, if you remember, it always starts with x equals, and it's equal to the x value of the vertex. So we would say that's x equals h. Okay, so the vertex is either the highest or the lowest point on the parabola. So for this little parabola I've sketched out here, hk would be that red dot. Okay, the axis of symmetry, I've cut that with a dotted blue line. We would say that equation is x equals h. And it says what determines the width and direction of the parabola? That would be our letter A. Okay, A determines the width and direction of the parabola. If A is positive, okay, if A is positive, then remember, we are going and opening up. Okay, the larger the value A has, the narrower it gets. If it's a fraction, it kind of flattens out and it has like a wider bottom. Okay, so if A is negative, negative A leads to an upside down or more of a rainbow shaped parabola. So vertex form shows the vertex, obviously, on a quadratic equation in respect to the parent function. So the most simple way that we could write a quadratic equation, remember that's without all of the extra stuff. So this would be f of x equals just x squared. Having x squared is what makes an equation a parabola. So the most simple way we could show that is to have one x and make it squared. On this next part, on numbers 1 through 6, we are going to describe how each function compares to the parent function. That means we're going to describe how it's like transformed or shifted from the parent function. And if you remember our parent function, quadratic, okay, it would have had a vertex that was starting or passing through the origin, through 0, 0. So how have each of these shifted from having a vertex at the origin? So on number 1, we're looking at f of x equals x squared plus 9. Now this is in vertex form, even though it's not as obvious. Now if we're looking up here at the top, okay, where I'm circling in yellow, you'll notice that it shows that we have parentheses, and it's x minus h in parentheses and squared. So what that's talking about is our squared term. Now if we are adding or subtracting a number inside those parentheses, that would represent our left and right shift because it's inside the parentheses with the x, and x's move left to right. But if you notice, we just have x squared. So we have this x squared term, but no parentheses. And what that's saying is that we shifted 0 spaces left, 0 spaces right. We wouldn't write x plus 0 or x minus 0. We just leave it as x squared. So there's no left-right shift here. This plus 9, okay, this represents, oops, I didn't mean to do that. This plus 9 represents our vertical shift because it comes after the x squared. So this is similar, again, to our absolute value functions. This plus 9 represents going up 9 spaces for our vertex. Okay, Okay, it's the same thing on number 2. Okay, here's my x squared. Because there's no parentheses, this tells me that I don't shift left or right any spaces. Okay, so no left or right shift, but this -2, that's my k value because it comes after the x squared, and this tells me to go down 2 units, or 2 spaces, however you want to think of it. Okay, on number 3, we have f of x is equal to negative and then x plus 5 in the parentheses, and all of that's being squared. Whenever we lead with a negative, okay, that negative is always a reflection across the x-axis. That's telling us arrows are headed down. So let's put reflect across x-axis. Okay, so I'm working left to right, and then as I keep working to the right, I can see that I have parentheses, and I have this plus 5 inside the parentheses before we have the squared on the outside. So that plus 5, again, we take the opposite only of our x values. That's going to mean a left 5 units or 5 spaces. Okay, so we had 2 changes on that one. On number 4, we have f of x is equal to x minus 4 in parentheses squared minus 1. So again, vertex form. I like the way this one looks. We have minus 4 inside the parentheses. When we pull it out, remember, because we could take this part set equal to 0 and solve for x. Okay, takes on the opposite sign when we do that. So it comes out as a positive 4, which means 4 spaces right. Okay, what does the minus 1 on the outside? Okay, what comes after the parentheses is our vertical shift. So this means that we are going down 1. We don't ever change the sign on our vertical shifting. Okay, number 5, I have f of x equals 1/3 x squared plus 2. Again, this is in vertex form, even though it's not so obvious. We do not have to have parentheses. Okay, just having it be x squared with no parentheses means that there was no horizontal shifting. But we do have to focus on what this 1/3 means. Okay, 1/3 in front of x squared, that's my a value. Okay, that's the number in front of x squared. The 1/3, because that is a less than 1 value, that means we're going to have a vertical compression of 1/3. Okay, or a vertical shrink, okay, of 1/3. And then we do not have any horizontal shift. Again, I know this because I do not have parentheses, and the plus 2 means that we are shifting up 2 spaces. And this should feel, again, very similar to our transformation rules when we did absolute value functions. Okay. Number 6, f of x equals -2, and then we have in parentheses x plus 4 squared. So let's break this apart. The negative is basically its own entity here. What does the negative sign mean? Because we look at the number separate from that. The negative means we have a reflection across the x-axis. Okay, that means we have arrows going down for our parabola. Then we get to our number 2 here. Okay, I'm thinking of it separately. What does that 2? We compare it to 1. It is greater than 1. So we have a vertical stretch of 2. Okay, so vertical stretch. It's going to be a little bit skinnier than normal. And last we have inside the parentheses, we have plus 4. Remember, we account for everything that's extra from just the x squared, the parent function. So we had 3 extra things. We have to account to all 3 things, 1, 2, and this third one. Plus 4 means when we take it out, it's -4 or left 4 spaces. Okay, so on number 7, we are working a little bit backwards. We need to write the function, the equation that represents what's being described in number 7. So if we're looking at this, it says Mason graphed the parent function of a quadratic equation. Okay, that tells me we're dealing with an x squared situation. It says then he reflected the parabola over the x-axis. He translated it 7 units up and 3 units to the right. What is the equation of the new parabola? Okay, so I know that this function, we're going to start with f of x. Hey, that's a good one, equals. Now, if I'm working left to right, it says reflected the parabola over the x-axis. Whenever we are reflected, arrows are going down, we're leading with a negative sign. So that takes care of being reflected over the x-axis. Translated 7 units up and 3 units to the right. I actually want to deal with a left or right transformation first because that happens inside the parentheses with the x. So I'm going to build some parentheses because I do have that right transformation. It starts with an x and right means minus. Okay, so minus 3 inside. X minus 3, when it comes out, it's a positive 3, meaning it moved right. And then we put our squared outside the parentheses because that's what makes this a parabola. And then we're going to end it with our up and down. 7 units up means we have a plus 7 on the outside. So this is represented by f of x equals negative, then x minus 3 in parentheses squared plus 7. And again, this reflects having a vertex at 3, 7, and that negative meant it was going down, reflected. So we're good. Okay, on number 8, we are wanting to give the vertex, it says, and the axis of symmetry of each equation or inequality, and then we're going to graph it. Now remember, whatever kind of function that has symmetry, we need to start by finding the vertex so we have that middle part of the function we're looking for and we get the true overall shape of it. So we usually are starting, find the vertex if it has one. Because this is in vertex form, and again, I recognize that because we have parentheses and then our squared sign and something being added after that. That's a big clue to me that we're in vertex form. So the vertex should always go in the middle of the table where I have it highlighted. So the x value of the vertex, it's the number that's with the x in the parentheses, but when it comes out, it has the opposite sign. So we have positive 2 for x. The y value of the vertex is the number being added or subtracted after that set of parentheses, and we do not ever change its sign. So the vertex is 2, 3. Again, I could write it again. It's 2, 3. So that means starting at the origin, we're going to go right 2 and up 1, 2, 3. And there's our dot. Okay, we are symmetrical about that. So what does that make our axis of symmetry? Your axis of symmetry is always the x value from the vertex. So we would say x equals 2. Meaning, okay, so right here, this axis of symmetry, this dotted line, okay, it's an imaginary line per se, but it's the point that we are symmetrical about. Now to graph the rest of this, you could use your table of values from your graphing calculator if you have one. If not, we're going to fill in values on either side of this. Okay, working to the left of 2 on the x-axis, we have 1, 0, and negative 1. To the right of 2 on the x-axis, we have 3, 4, and 5. And we can plug these values in. If I start with negative 1, I would have in parentheses negative 1 minus 2 squared plus 3. Okay, you can work it out by hand. You can type it into your calculator. But we're going to get, let's say, negative 3 squared plus 3. This is 9 plus 3, which equals positive 12. Okay, so we put that in our f of x or our y column. Next, we would plug in 0 for x. So we're going to have 0 minus 2 squared plus 3. Okay, this would become negative 2 in parentheses squared plus 3, which is negative 2 times negative 2 is positive 4 plus 3, which equals 7. Okay, so when x is 0, y is 7. Next, we plug in 1. Okay, I'm not going to show it all on here for the sake of I don't have very much room, but again, you know how to plug things into your calculator. Next, we're putting 1 in for the x. 1 minus 2 is negative 1. Negative 1 squared is positive 1. Positive 1 plus 3 is positive 4. Okay, so we should be expecting symmetry because all parabolas are symmetrical about the vertex. If I plug in positive 3 for x, I get 3 minus 2, which is positive 1. Positive 1 squared is still positive 1. Positive 1 plus 3 is 4. So these are going to start repeating. Okay, so that makes when I plug in 4 for x, I'm going to get 7 for y, just like I did when I plugged in 0. When I plug in 5, we get 5 minus 2 is 3. 3 squared is 9. 9 plus 3 is 12. Okay, so these 2 points match up. And again, we should expect that because we are always symmetrical about the vertex, about our axis of symmetry. So at 1 we are 4, and at 3 we are 4. On moving one space out from that, we are at 7, so 5, 6, 7 here, and 0, 7. And we cannot plot at 12, but we do know it's kind of shooting up the arrows. So here we go. There we go. So using that vertex form does make things a little bit quicker. Okay, on number 9, my function is f of x equals x squared minus 4. Again, we want to give the vertex and the axis of symmetry and then graph the rest of the function. Now, x squared minus 4, it may not seem like it's in vertex form, but it is. If I have the x squared term that does not have any parentheses, if it's just x squared, no x minus or plus a number in the parentheses and then squared, that means I do not have any horizontal shift. So that means the x value of my vertex is 0. Okay, no shifting left or right means 0 is that x value of the vertex. Now, what's the y value of the vertex? It is the k value, which is the last number being added or subtracted after our x squared. So that would be -4. So 0, -4 is our vertex. So stay at the origin and go down 1, 2, 3, 4 points and plot the dot. Okay, now remember that's also the vertical line which our axis of symmetry lies on. Okay, so this is our vertex. We'll label it, and our axis of symmetry, A of S I'm going to call it, starts with x equals always, and it's equal to 0. So it is on the y-axis. That's the same equation. Okay, let's fill in the rest of our points. To the left of 0, we have -1, -2, -3. To the right, 1, 2, and 3. We're plugging these values in. If I start at the top with -3, I have in parentheses because we always use parentheses when we substitute numbers in for variables. So -3 squared -4. This is +9 minus 4, which equals 5. Okay, we can put that there. Let's plug in -2 for x. We have -2 in parentheses squared -4. That's +4 minus 4, which equals 0. Okay, next we plug in -1. So we have -1 in parentheses squared -4 becomes +1 minus 4, which equals -3. Okay, because I know we're symmetrical about the vertex, I know that on the opposite side of -4, we will also have -3. Okay, on either side of my -3's, they will match up and be 0. On either side of that, my numbers will match and be 5. Gotta love symmetry. So let's plot these points. So when x is 1, y is -3. So we just went up one value. And then on either side of that, for x, we are passing through 0 for y. That's not 0. Make sure you actually plot it on the right value. Here's 0. And then on either side of that, we're up at 5. So 1, 2, 3, 4, 5, and 5. Okay, connect your points. And again, all parabolas have rounded on the bottom or by our vertex, not points, okay, not absolute value. So here we go, and that's finished. Okay, number 10, we have f of x is equal to negative, and then in our parentheses we have x plus 5, all being squared, subtracting 1. So starting by finding our vertex, okay, we look inside, we take what number is with x, and we take out its opposite, so -5 for x. The y value comes from what is being added or subtracted, and we do not change its sign, so it's going to stay -1. Okay, hopefully we see it. So we have -5, -1 for our vertex. So that means we start at the origin, go left 1, 2, 3, 4, 5, and down 1. Now what about this negative sign on the front? Before we even get into the parentheses, what's its job? Remember, that's our A value. When we lead with this negative, that tells me that my arrows are going to end down, that my parabola was reflected across the x-axis, or arrows are going down. So if we get values where our arrows are not going to end up going down, that is a clue that we did something wrong, because that negative sign means that those arrows have to do that. Okay, so let's finish filling in our x column. To the left of -5, we have -6, then -7, then -8. To the right of -5, we would have -4, -3, and -2. So let's plug in our x values. And again, lots of calculator work, or graphing calculator gives you a table of values if you're using a graphing calculator. Remember, we get to that by we type in the function exactly as we see it, and then we would do second graph to get the table of values. But we would have negative, and then parentheses, we have -8 plus 5, all of that's being squared, -1. So we have -8 plus 5 gives us -3 squared -1. So we have negative, and then -3 in parentheses squared is +9. So, but when it comes out, it's getting multiplied by the negative out front to become -9 again, subtracting 1, and we get -10. Okay, so -10. Now really, we can just keep using, even if we're using our calculator, we can keep going through. We're just changing this x value. We could go in with our calculator and change that to -7 next, and then -6, and so on. When we plug in -7 for our x, we are going to get a y value of -5. When we plug in -6, we get -2. And again, I know these points are symmetrical about the vertex, so that means when I plug in -4, we will get -2. When we plug in -3, we'll get out -5. And when we plug in -2 for x, our y value will be -10. Okay, so again, we know our vertex. We forgot to write down our axis of symmetry. So axis of symmetry always starts with x equals, and it's x equals the x value of your vertex, -5. That's where we cut that parabola in half. So it's about this point right here, this line. Okay, so plotting our points, we have on either side of -5, we are at -2. So we're actually going down 1 on either side. On either side of that, we are at -5. So -3, -4, -5. And on either side of that, we would be at -10, but we don't have enough space to put those points. But I do know that it's just shooting down. And make sure it's rounded. Okay, so we have our axis of symmetry, we have our vertex, we have our rainbow. So I think we're good. Okay, number 11, we have f of x equals 3 times x minus 4 in parentheses, all being squared. Okay, we are again in vertex form. I want to start by putting my vertex in the middle of my table of values. My vertex, the x value comes from the number that's inside the parentheses with the x. If it's -4 inside, it comes out as +4 because that's our rule. The k value represents the y value. That's what's being added or subtracted after it. It should be a number right in here. There's no number being added or subtracted, so that's like the same thing as saying +0. So we're going to put a 0 in our y column. So that's our vertex for 0. So let's go from our origin. Let's go right 1, 2, 3, 4, and plant our dot. Okay, filling in the rest of our x column, we have 3, 2, and 1 as we move to the left, and 5, 6, and 7 as we move to the right. Now filling in these values, maybe let's erase this so it looks a little bit neater. Okay, we're plugging in 1 for x. We have 3 parentheses 1 minus 4, all being squared. Again, a lot of calculator work. If you're working it out by hand, that would be 3 times -3 in parentheses squared. Order of operations, we would have 3 times +9, which equals 27. If you don't believe me, type it into your calculator. So when x is 1, y is 27. When we plug in 2, out's going to come 12. When we plug in 3 to this function for x, again, we're just replacing all those x's, we are going to get out +3. And again, because this is symmetrical across the vertex, when we plug in 5, we also get 3. When we plug in 6, we will get 12 out. And when we plug in 7, we will get 27. Now, we can't plot all these points. We'll plot as much as we can. But if you remember from our transformation rules, okay, this 3 here on the outside, that's a value greater than 1, which meant we had a vertical stretch, which means our points are increasing very quickly, like shooting up, and so we have a lot skinnier parabola here because of that vertical stretch. So that'll help us like kind of know how to do our arrows at the end. So we already have 4, 0, and then on either side of that, we are up to 3. We're not increasing by 1, we're going up to 3. So 1, 2, 3. So let's get on the pin. On either side, so 3. And then on either side of that, it's at 12. Now, 3, 4, 5, 6, 7, 8, like 12, it's going to be like way up here. Okay, we're just going to guess. And I'm doing that to show that this is really going to be a very narrow or skinny U here. It was vertically stretched, and our arrows are close together. Okay, not very separated there because of, again, of this 3 on the outside makes it stretched out. The larger that number is, the skinnier that they get. Okay, on number 12, it's a little bit different. We're back to having a piecewise function. Okay, piecewise because we are allowed to graph two different pieces from two different equations on the same coordinate system. Okay, so we're saying that f of x equals negative 1/2 x minus 6 if our x values are negative 2 or smaller. We're saying that we could also equal x minus 1 in parentheses squared minus 5 if our x's are bigger than negative 2. So we're, again, allowed to graph for a certain domain, just different pieces of these lines. So if I'm going to start, I'm going to start with the top function, negative 1/2 x minus 6. Now, if you remember, when we start these, we always look at our domain, and we say for x's that are less than negative 2. You always start both tables, actually, with that number for x. Okay, we just maybe have an open or a closed circle at that point. Now, numbers that are smaller than negative 2 would be like negative 3, negative 4, negative 5, and negative 6, and so on. We're plugging these values in for the x in the equations. For example, it would be negative 1/2, then x we would plug in negative 2 and subtract 6, and we would get out negative 5. Okay, that's going to be my first dot, and that will be on the wall that we'll put in here in a minute. Then we're going to plug in negative 3. We have negative 1/2 times negative 3 minus 6, and that's going to equal negative 4.5. Ugh, fraction. Some of you are like, I don't want a fraction. Remember, we don't always have to graph the fractions. That's okay. Our next value would be negative 4, so we're doing negative 1/2 times negative 4 minus 6, which will equal negative 4. When we plug in negative 5, we will get negative 3 and 1/2, and we plug in negative 6, we get out negative 3. Now, we have enough points. See these ones with fractions? We don't need to plot those just because we got them on our tables. We have enough to plot all of our whole number points. But remember, before you start plotting your points, if you're doing it this method, put your wall in first. Both numbers have to start the wall. Our wall that passing through negative 2 for the x-axis will be right here. And I love starting with that wall because, again, I know my first circle has to be on the wall, and we have arrows or lines that are coming out in either direction from that wall. Okay, they can't be on the same side. So my first point that we're going to plot is negative 2, negative 5, but I'm checking, is this going to be an open circle or a closed circle, because that's the point on the wall. And because it's just a less than sign, not or equal to, it will be an open circle at negative 2, negative 5. So here's 1, 2, 3, 4, 5. Okay, open circle. The next point I'm going to plot will be negative 4, negative 4, because I like plotting the whole numbers better. So I'm going to go to negative 4 and down 1, 2, 3, 4. Right here, put a dot, and I'm going to skip over negative 5 and go to negative 6, negative 3, right here. So we have a diagonal line shooting out from the left side of the wall. Okay, that's one piece of our line. Now our next piece is going to generate a different type of line because we're doing x minus 1 in parentheses squared minus 5. Anytime I see a squared, I know that I'm getting a parabola. So we're going to get a part of this parabola. Let's see how much of it we're going to get. Because our domain is x is greater than negative 2, we still start with negative 2 on our table, but we're doing values that are greater than negative 2, so then we would say negative 1, 0, 1, 2, 3, and so on. So plugging in negative 2, again, in your calculator, that would kind of look like we have started with parentheses negative 2 minus 1, close your parentheses squared, and then we have minus 5. We type that into our calculator, we're going to get out 4. So we're at negative 2, positive 4 for our first point. Okay, then we change it and we plug in negative 1 for x. So we have negative 1 minus 1 squared, then minus 5, and that's going to equal negative 1. Plugging in 0, we would have 0 minus 1 squared, then subtract 5, and we get negative 4. Okay, we keep going on. Plugging in 1 for x, we're going to get negative 5. And again, okay, I should know that's the vertex if I'm looking here. Out from here, the vertex form, we get positive 1 and negative 5. So to me, that tells me that's my vertex. And about this point, we're going to start having symmetry. When I plug in positive 2 for x, I have 2 minus 1 squared is 1, and 1 minus 5 gives me negative 4. So I know that these points are going to start repeating. When I plug in 3, I get negative 1, if I plugged in 4, I would get out 4. So let's plot these points. Now, at my first point that I circled at the top, I'm going to have an open circle because it was just greater than, not greater than or equal to. And so that's on the wall. We're at -2, but +4. 1, 2, 3, 4, open circle. Then we're at -1, -1. Okay, so we're down here. Is that -1, -1? Yep, down here. And then we are at 0, -4, so 0 and 1, 2, 3, 4 down. And then we are at 1, -5, and then 2, -4. We're going back up now. We had our vertex, that was our turning point. Now we should start shooting back up. And then we're at 3, -1, and we could continue on. We'd be at 4, 4, and so on. We're going to curve downwards to our vertex and turn back up. Okay, there we go. Those are our 2 lines. Again, piecewise, we have a piece right here shooting to the left from our wall, from our domain division, and we have a piece of a parabola. Okay, very fun. Okay, on number 13, we have another piecewise function. Okay, 2 different equations where we can graph pieces of them. We have -2x² + 6 if our x's are less than or equal to 1. And our second equation is -3x + 4 if our x's are just greater than 1. So because of my domain right here, I have a dividing point at +1. That's where I'm going to place my wall. +1. It's coming out of that wall going in opposite directions. One I know will be linear, diagonal. One will be part of a parabola because we have an x². Those are things I know right now just by looking at everything. So starting with the top equation, -2x² + 6, the first number I'm putting in my table is going to be +1. And then I'm saying numbers that are less than 1 would be 0, -1, -2, -3, and so on. So we're just substituting these values in for x. Okay, again, in this equation that I just circled, we're going to have -2 times 1 squared plus 6, and we get out +4. Okay, next plugging in 0. We have -2 times 0 squared plus 6, and we get 6. And again, I do know that should be my vertex right here, just by looking at what we have up here. And I do know the arrows should be going down because we have a -2 in front of x². Okay, moving on, we're going to plug in -1, -2 times -1 squared plus 6. We get out 4. And again, can you see how we're having symmetry, that 4 repeated? And again, that's another clue that we had our vertex at 0, 6. Plugging in -2 for x, we have -2 times -2 squared plus 6, and we get out -2. And when we plug in -3 for x, we get out -12. Okay, now we have all of our points. We're ready to graph this line or curve, and we know that we should check this first point, 1, 4. Is it an open circle or a closed circle? And because my sign up here is a less than or equal to, that tells me that we have a closed circle for my first point on the wall. So when x is 1, y is 4. So 1 and 1, 2, 3, 4. Okay, my first dot is closed. Then we are at 0, 6. So 4, 5, 6. We go up, okay, because that was my vertex. And then we're going to turn. That's a vertex is also a turning point. We're going to start going down. When x is -1, we're at +4. And then we are at -2, -2. We're down here. And then we'd be at -3, -12. So we're just kind of going down kind of rapidly at this point. So let's make our curve here. And again, it's making a piece of a parabola. Okay, there we go. Okay, now we're going to have a line that is coming out of the right side of this vertical wall that we made at 1. So I have my next equation and a next table of values. We're doing -3x + 4. Because x is not squared, I know this is a linear equation, a diagonal line. I'm going to start by plugging in 1. Okay, start at that same number. They both need to be starting on the wall. Greater than 1 would be 2, 3, 4, and so on. So we're going to start, we're going to get -3 times 1 plus 4, and that equals 1. -3 times 2 plus 4 is equal to -2. Okay, negative 3 times 3 plus 4 equals negative 5, and negative 3 times 4 plus 4 equals negative 8. Okay, my first dot will be on the wall at 1, 1, but this is going to be an open circle because we just said greater than 1, not greater than or equal to. So when x is 1, y is 1, open circle. When x is 2, y is negative 2. When x is 3, y is negative 5. So 2, 3, 4, 5. And then when x is 4, y is negative 8. Okay, we could answer domain and range. Our domain would be all real numbers because we have open and closed. And my range, we are all the y's that are less than 6, it looks like. But that wasn't really part of the question. But just for those of you who wanted it, because I just know you love doing math. Okay, 2 more examples. On number 14, we don't have piecewise anymore. We have an inequality. Okay, oh, I didn't mean to do that. I thought I was on my highlighter again. Okay, we have a less than sign right here. Okay, so that just means I'm going to plot all my points and fill in my table the way that I usually do, but then before I connect my points, I'm going to decide is it a dotted or a solid line that connects these points, and we will have shading either above or below this vertex. So let's look and start with the vertex. We always start with the vertex. Okay, the vertex is in the middle. I take for my x value the number that is with the x and I change its sign. So it was negative 3, it becomes positive 3. The y value comes from what's being added or subtracted outside of it. I'm looking for something over here. I have nothing, so it's like saying plus 0, making our vertex at 3, 0. Okay, so we're going to go right 3 and not up or down any right there. Okay. What else do I know by looking at it? I know that this is going to be a rainbow or a sad parabola, I'd call it, because of that negative. And I told you negative people are sad and frown. So rainbow or frown, however you want to think of it. Now I'm working out an outward direction from my vertex on the x-axis. So to the left of 3, I have 2, 1, and 0. To the right of 3, I have 4, 5, and 6. And again, because I know that this is reflected across the x-axis, it's a negative parabola. I know that my value should be getting smaller than 0 in my y column. Okay, so let's plug in 0 for x. We would have negative, and then in parentheses, 0 minus 3, all being squared, and this will equal negative 9 for y. Next, we plug in negative 1, so we have negative sign, and then parentheses, 1 minus 3 squared, and that's going to equal negative 4. Okay, again, these are all values smaller than 0, so that's a good sign to me. We're plugging in 2, so we have negative, and then 2 minus 3 squared, that equals negative 1. Okay, I could keep continuing to plug in values, but I do know that these are symmetrical, so my next point on the opposite side of the 0 should be negative 1. My point after that should be negative 4, and then negative 9. So we'll make these dots. On either side of my vertex, we are going down to negative 1. On either side of that, we are going down to negative 4. And on either side of that, we'd be negative 9, but I don't really have it on here. We only have an 8 by 8 grid. But I'm going to stop now, and I'm going to look at my sign. Okay, the sign here was this sign. This sign is a less than sign. So that tells me, again, 2 things. I'm having a dotted line, not solid, because I didn't have the or equal to bar. So we'll do a dotted line to connect our points. And then shading, less than. Numbers that are getting smaller are going to be below. So we are shading below the vertex. So here's my, oh, where it happened. Vertex would be below this point. So everything underneath here. So that was the extra bit we added because we had the inequality, or as I know a lot of you like to call it, the alligator thingy. Okay, number 15, we have f of x is greater than or equal to 4 times x plus 1, all being squared, minus 7. Okay, another inequality, so another possible dotted solid line situation and a shading situation. We still start by finding the vertex. The x value of the vertex comes from the number that's inside the parentheses with x. It's positive 1 inside, so it comes out as negative 1. The y value is what comes after that. We do not change its sign. So our vertex is negative 1 for x, -7 for y. So 1, 2, 3, 4, 5, 6, 7, right here. I do know two things. My A value on the outside, that's the A value. 4 tells me because it's positive, it's going to be opening up. Okay, arrows ending up. And it's going to be fairly narrow, fairly skinny, because we had a big vertical stretch here of 4. Okay, times 4. So those are things that we're expecting to happen here. Now, plotting points to the left and right of -1. To the left of -1, we have -2, -3, and -4. To the right of -1, we have 0, 1, and 2. Okay, we plug these into our equation and solve. So we would have +4 on the outside of the parentheses, and then inside -4 plus 1, close it, all being squared, -7, and it's telling me we get 29 for y. Next, we plug in -3 for our x's. So 4 parentheses -3 plus 1 squared -7, and we're going to get out 9 for y. Next, plugging in -2 for x. So 4 on the outside. Again, that's what our equation starts with. It starts with 4 times -2 plus 1 squared -7. If you're not getting these answers, I would maybe check to see that you are squaring, have your exponent on the outside of your parentheses. Okay, and we would get -3. Okay, we already have our vertex in at -1, 7. And then we could keep plugging points in, or remember about our symmetry, which you've heard me say like 5,000 times at this point. So we have 9, and then on either side of that, we get 29. Oh, those are some really great lines. Okay, so on either side of my vertex down here at -1, -7, we have 0 and -3. 1, 2, 3, dot. On either side, -3. And on either side of that, we're going up to +9. See how it's going to make it really skinny? When x is 1, y is +9. And this is a 8x8 grid, so 9's going to be right here. And then on this line, we're up here too. So see how really skinny it is? Again, that's because of that +4 outside the parentheses. Vertical stretch. It's a real thing. Now, before I connect these points, I'm going to look at my inequality sign. Okay, this sign. Let's write it down over here. This was a greater than or equal to sign. Because it has that solid line underneath, I'm using a solid line to connect my points. Okay, try your best. I don't always do a great job. Do better than me. Okay, so there's my parabola. And now my second thing, so we had a solid line. Where's our shading? Above or below? Greater. Numbers are getting bigger. That means numbers that are going up. So we're shading above the vertex. So here's my vertex. Above is everything inside of it. All right. Have fun. That's the end of our lesson.